because I have to do so many things.
No.
Yeah, they are coming from a landing page and also from a link from Zoom.
No, I'm wondering, like, what do they see right now? Would it be better for us to show them the first slide?
Yeah, the first slide. Yeah, they will be seeing the first slide and they will be seeing side gallery of all of us.
Okay.
Okay. John was asking how many people registered. Stephanie?
Okay, now we can start. We're ready.
Great.
They're summing up the people.
Okay, we can start when you say, Stephanie.
Yeah, we can start. We can start now.
Great. Good evening, everyone, and a warm welcome to our webinar From Data to Execution, AI in Business. I'm Victor, your host for this evening, and I'm delighted to have you with us. Join us as we dive into the transformative role of artificial intelligence in business, guided by an expert in the field, Jonathan Conradt. Before we begin, just a few housekeeping items. This webinar will last approximately 1 hour. We encourage you to submit your questions throughout the session using the chat box, and a recording of the webinar will be available after the session for those who registered. Now, AI has become a transformative force across industries, helping businesses streamline operations, enhance decision-making, and unlock new opportunities. But what exactly is AI? And how does it work? And why is it so important in today's business landscape? We will know the answers in just a few minutes. Taking into account there is a Spanish-speaking audience, I'll take a moment to share with you a few tools Nova has available for you in the AI field in Spanish. Okay, so I'm going to switch to Spanish a little bit, and then going to go back to you, Stephanie, to take the lead. Tenemos a Raiza, un agente con el potencial de incrementar ventas y reducir costos para empresas en retail y B2B usando un avatar digital en tiempo real. Tenemos a GTM System, un agente AI que localiza clientes en LinkedIn, dándole vida a tu inversión en LinkedIn. Customer Assistance, un agente que responde tus llamadas y mensajes promoviendo ventas e incrementando la satisfacción de tus clientes. Y Social AI, un agente que vive en tus redes sociales y captura conversaciones de miles de personas para promover ventas, lealtad y recompra. Okay, Stephanie, please take the lead.
Okay, so thank you very much to everyone joining us today at this event. We are entering an era where AI models are not just built for one specific task, but are adaptable and reusable across industries. Think of AI as a multiple purpose tool rather than a single use solution. This evolution opens doors for businesses that want to implement AI without needing custom built solutions every time. So throughout this event, we will touch on topics such as introduction to artificial intelligence, the traditional computing science versus artificial intelligence, the dawn of reusable, fungible AI, what are large language models like ChatGPT doing, Synerise Business AI, conversations with technical manuals and sales brochures, and how to glue on when you need AI but don't have scientists. So remember, everybody, we want to encourage you to submit to your questions throughout the session via the chat box below on the webinar, and also the Q&A hand on the bottom of the screen, so you can ask any questions if you like. So, Victor Andres, aren't you excited for this AI industry?
Hell yeah, I am. Especially the topic related to large language models, aka LLMs, like ChatGPT, Gemini, Grok, and so many others, which have revolutionized the way business interact with customers, create content, and even automate process. Also, tools like AutoGlue, developed by AWS, aka Amazon Web Service, allow business to deploy AI solutions with minimal expertise. which is actually a game changer for companies to look into harness AI without a massive investment in specialized talent. Now, to help us navigate through these questions, I'm honored to introduce our esteemed speaker, Jonathan Conradt. Jonathan has an incredible background in AI and machine learning. He was a principal AI research for AWS, a lecturer for Amazon Machine Learning University, and has held leadership roles at companies like eBay, Google, and Microsoft. He holds multiple patents in AI and marketing, and his work has had a significant impact on the industry. Jonathan, welcome to the show. The floor is yours.
Well, thank you very much. Sometimes I wonder if these introductions are written by ChatGPT, so you'll have to tell me later. All right, so what is artificial intelligence? Artificial intelligence is the effort to create something that's indistinguishable from a human being. And there's lots of ways we could potentially do this. Potentially you could do it with physics or with chemistry, but where we've had the most success has been in computer science and math. So if we think about what AI is going to do, what makes it different than other kinds of things is AI makes predictions. So here we have a chart which shows a prediction of how much a house is going to cost based solely on the square footage. And as you can see from the dots, which is the actual home prices, the line that's making the prediction is doing okay, is doing all right. It's not doing great. And because, there's other aspects that go into a home price. For example, how good is the school system in that area? How many floors does it have? Does it have a pool? The crime rate in the area. There's lots and lots of additional factors. And so the beautiful thing about AI is it can consider more than, say, one variable. It could consider thousands of variables. And so you can get much better and much more sophisticated predictions through AI. So what's the difference between traditional computer science and AI? You could write a computer program that tries to guess or predict a house price, for example. And how would you do that? Well, you would gather a bunch of data. You would sit down, try to figure out the rules. You would hand code all of the rules into a program. You probably have some tests that you would run where you'd take some houses, you'd run it through the program, and see how well it did. The difference with AI is that instead of a human being trying to figure out the rules and writing all the code, what you actually do is you provide it with examples, thousands, millions, maybe billions of examples. And the algorithm itself is looking for the patterns and learning the patterns from the examples. So in some ways, the human being did the same thing when they wrote their program, but it's hard for a person to conceptualize how to use the data from, say, like a computer camera, right? If you want a self-driving car, it's a lot of data flowing in. And what is the rules that a programmer should write down so that the car understands that this is a person or a tree or a stoplight? It's very hard, very complicated. But with AI, you can give it many examples just of the video itself, and it'll start to figure out what the different shapes are. That's it. So the examples are, in many ways, the code. So how can you as a company prepare for machine learning or AI? Well, if the examples are the code, then you need to think about, are we preserving our data? Do we have a record of, say, all of our transactions, of all of our invoices, of the things that our employees did, the time, the time cards, like how much data do we actually have? A long time ago, I was hired by eBay, and I sat down and had a good conversation with their CTO at the time. And I asked them, well, how much of their data was available online right then? In other words, how much was sitting on a disk that I could access it? And he said that they only kept about 3 months, maybe 5 months worth of data available at any one time. And I said, well, that's a disaster. That's absolutely a disaster. Like, if I were to train a machine learning model using the data you have available, that machine learning model has never heard about Christmas. It has no idea that Christmas is coming. Like, that's a big problem in retail. And he agreed, and he said there was a project they were starting. They were going to bring online 4 years of data. When I got to Amazon, I found out that very early, Bezos recognized the power of having and retaining data. And so they tried very hard to basically keep it all online for as long as they could. And so when it came time to, Amazon became famous for being able to recommend products to you. And those were early machine learning models because they had the data. They knew the people that bought this also bought these things. And so what are you doing? Is your data available? Like, can we go back and we see the records that your business has operated on for years, hopefully, because we don't want to have just one Christmas shopping season. We want to have as many as possible, for example. So then the other issue is your data clean? If you have automated systems, like say an e-commerce platform that you're using to run a website, you can keep your data pretty clean. It's all going to go in there nice and clean because the systems are well organized and they're all digital. But of course, many businesses, that's not the case. You've got handwritten receipts, you've got handwritten, invoices, those kinds of things. What can you do to try to improve the quality of the data? So you don't have missing data, you don't have incorrect data. That's a big task for you. And that's one of the first tasks you have to take on in order to take advantage of machine learning and AI in your future. Okay. With machine learning, it used to be that you would train them an algorithm for one task. Let's say that you were trying to predict how many Coca-Cola cans you should have in stock, right? So you have the data. You have how much stock you ordered, how much stock you sold for years at a time, and you have some other data like how hot it was that day, did it rain or not? I don't know, some sort of data that you could maybe make the prediction from. And so what you would end up with is you would have a scientist take this data, try a few things, try to come up with a machine learning algorithm that can make that prediction. And so you have one set of data producing one prediction. And then if you decided, oh, well, actually what we want to do is we want to predict milk. Well, they would actually have to start a new project. So they would get all the milk data and they would train a new model, and now you've got the milk algorithm. So that's kind of traditional machine learning. You're training it on examples. Those examples are very specific to a particular goal. And so with traditional machine learning, if you change the goal or you change the example data you're providing, you're starting off, you're getting a whole new algorithm. Of course, the other thing that happens is, this is my experience at Amazon. We had all these great machine learning models. They predicted all kinds of great stuff. And then the pandemic happened. And suddenly, behavior on Amazon before the pandemic was not useful. People were behaving completely different during the pandemic. And so our machine learning models, they didn't know what to do, right? They were just wrong all the time. But then what happened? The pandemic, unfortunately, didn't go away after 2 weeks. It went on for a long time. In fact, it went on long enough that pretty soon the normal behavior was the pandemic behavior. And so we started having this really interesting debate among ourselves as scientists. We can't use those examples for the post-pandemic period. We expect behavior is going to be different again. But is the behavior going to be like the pre-pandemic behavior? Can we drop back to that? So machine learning algorithms, those models are very closely related to the data that you have. They take one type of data and produce one type of result. But what if you could do something more sophisticated? And so in this case, we see the idea of let's train a neural network, which is a complicated, very complicated algorithm. And in fact, it could be very sophisticated. So potentially you could have it solve multiple problems. So ChatGPT is an example of one of these things. So what makes large language models like ChatGPT so powerful is a couple of things. One is they're very, very large and complicated. So you can imagine that a machine learning model that's going to predict the cost of houses, and it has maybe 100 variables coming in, it's really small. It's really small, right? But ChatGPT or these large language models that you hear about, just the data that represents the model, right, which is the thinking part of the model, it's the same amount of data as about 39 hours of video, a full screen 4K surround sound video. So if you watched every Marvel superhero movie, I don't think that's 39 hours. Maybe it is, but like that's an enormous amount of data. And what is it trying to do? It's trying to predict the next word so it can answer your question. So these things are very large and very complicated, right? So the traditional machine learning model is tiny, super crazy fast, very, very cheap. These large language models, they're called large for a reason. And so you have that sophistication. And then how do you train it? So with a traditional machine learning model, you show it several thousand, hopefully 100,000 examples of something, it does a good job. Something this large and complicated, to train it takes an enormous amount of data, like the entire internet. Like let's just take all of it. Every word anybody's ever put on the internet in every language, right? Every picture that's ever been on the internet. Let's just take all of it because we're going to need that much complexity in the examples so that later on when we ask it to do stuff, it can draw from all that data. Not the data itself, but the lessons it's learned from the patterns in the data.
Jonathan, before you go to the next, I think you didn't introduce yourself because the people can know about you.
I'm sorry.
Yeah.
I thought Victor did a really good job doing that.
Oh, okay.
Yeah. Otherwise, my LinkedIn profile is on the first slide. You can click through that, and it's also on a later slide if you want to go look at that. But yeah, I liked Victor's introduction. I thought he did a good job. Even if ChatGPT wrote
Yeah,
it, it was
it's fine.
Okay, so that's ChatGPT, right? It's an enormously complicated thing that's trained on
Well,
an enormous
it wasn't
amount.
him. It was Grok.
I'm sorry.
Please
Oh,
go
you
ahead. Please go ahead.
use Grok instead? Okay, well that's fine. It was a large language model. All right. Now, what if we took this idea of instead of creating a very specific machine learning model, what if we again used a neural network like a large language model uses? And what if we trained it not on a specific business problem, but we taught it the relationship between your customers, your products, and the way those two things interact? So you could kind of think of it as a sentence, right? So you have a noun, you have the verb, which is the interaction, and the subject, right? A large language model learns the relationship between these three things, and it can answer a wide variety of questions, and it can finish a wide variety of sentences. And so this European company called Synerise, they've done the same thing with your business. So the beautiful thing about this is you can train this model on your own data very quickly, and then ask it specific questions like who's not going to come back again as a customer, right? So we should reach out to them and prompt them to come back, give them a coupon or something. What item are they likely to buy after this one, right? What item are they likely to buy at the same time as this one? What item are they going to buy today because of the things they bought in the past? There's over a dozen different machine learning business solutions, all based on that one neural network. That's a really powerful idea.
Do you have an example that you can share with us, or a case study or use case study?
Yeah, so they have a wide variety of case studies, but a specific use case that they have is early on as a business, they started working with in the United States, they're called 7-Eleven, right? They're these convenience stores around the corner. They sell sodas and cigarettes and some food, and right, they're small stores that are very convenient, in and out, away you go. And they formed a very good relationship with them. Well, there, in this case, you have a huge volume of people coming in and out, so they have to be very, very fast. And what they did is there's an app for your phone that you actually use to get in the store. So you go up, scan your phone, the door opens, and in you go. You buy your stuff. You grab your stuff. You just walk out, and it figures out what you grabbed and charges you. But because you're on your phone, and it knows you're in this store at this particular time, so the model knows what inventory is available. They send you coupons and offers directly to your phone. Like right now, Diet Coke in the 2-liter bottle is 10 cents off for you. And so you immediately get this, you're standing in the store, you immediately get the offer. It's personal to you. The next person to come in, they get a different offer that's unique to them. And it's just that fast, right? So these are, Synerise does a fantastic job. They have representatives that service companies in Central and South America. I'm happy to get you in contact with them. I'd be happy to make that introduction because I think they do a fantastic job. I think it's a great idea. It's a great product. Medium-sized companies are going to have a really hard time doing machine learning. I'll show you a way that you can do it. Most medium-sized companies, you're going to have trouble just hiring scientists, right? And then the scientists have to learn the stuff and learn your data. Synerise has kind of cut through all of that. When I saw what Synerise could do, I thought, okay, there's no job for me anymore at Amazon, right? This idea of having a reusable AI that understands my products, my customers, and how they interact is a brilliant idea. So that's what Synerise did.
Super powerful. It's incredible.
Yeah.
Yeah, it's great. So what's a practical thing you can do with a large language model in your company or any company? An interesting thing you can do is actually have conversations with your documents. And so what this means is you can create an account, upload your documents. Maybe they are your policies, maybe they're your product catalog, maybe they're your vendor's catalog, it's whatever data that you have. You can upload those things. The documents are divided up into nice little chunks, okay? And the model, what it does is it establishes a mathematical meaning for that chunk of data, right? Because all of these models, they only work on math. And so the words and meaning are converted into a number that represents all of that meaning. The number is huge, by the way. It's 8,000 dimensions, this gigantic number. But there you go. And then later on, when you are asking questions or you need to know something, it takes your question, converts that into a number and says, okay, what are the answers that are in the neighborhood of this number? It goes and grabs that. And then when the large language model is writing its response, it's able to draw from the actual answers in the documents, right? And so you get a grounded factual response from actual documents. In fact, they'll even point you back to the original document. So you can go see the original text, make sure you understand it. So this is a fantastic tool for improving search. Keyword search has got many limitations. This is much more sophisticated search. You can just ask a question. It's great for training, bringing people up to speed quickly. It's great for customer service. So if someone's trying to find a solution to a problem and you provide a little chat bot that is backed by your FAQs and your product information, they can hopefully find what they need quickly. So that's a really common, simple use of a large language model that you can use without having to, clean up all of your old data. It's like take the most recent documentation you have, upload it to the model, and start asking it questions.
So I have
But
one
you're talking
question.
about, sorry, go ahead, Stephanie, go ahead.
Oh, yeah. So with that of the paperwork the due diligence that businesses need to do before entering to the AI solutions. So first they need to clean up their house inside. So the large language models and all these AI solutions, they can grab the information somewhere if like clean data. They need to have first clean data and clean everything to be uploaded on the.
Yeah, so there's kind of different scenarios, right?
Okay.
So if you're going to do traditional machine learning, where you're going to train a model on your historic data, yeah, it has to be really clean, right? Because this model has no other source of information, right? And so the only thing it knows is what you just gave it. But with a large language model, that's not true, right? Large language models have an enormous background in language and facts from when they were trained. And what you're doing is, in this case, you're providing it with very specific documents that it can go and use to answer questions that are timely and accurate and correct, right? Because my mom used to run a business where she sold and repaired hand tools, like saws and that kind of stuff. I mean, electric saws and things like that. And every year there were new models. There's an enormous number of parts that are in these things that she's trying to repair them. And a large language model doesn't know that stuff because those documents aren't available to it on the public internet. They're only available to the people that have license to sell the stuff, right? But she can upload that document, and now when she talks to the large language model, it does know those answers, right? So she can ask it complicated questions about a specific tool and get the exact part of the manual back.
But you're still talking about the LLM, a journalistic LLM, Grok 3, Claude 3.5, Gemini 2. You're talking about that kinds of LLM.
Yes. Yeah.
What about the personal assistants or the personal companions? I mean, if someone in the audience right now has a small company and they want to have a very specific LLM that will feed from the information of their company, learn from that information, as Stephanie just mentioned, clean data, and support this entrepreneur because knows very specific things that happens in that company. How do you think people from the audience can take advantage of that?
Yeah, so that probably isn't a reasonable thing for even a large company to do. Like, so what I hear you saying is, could a company that is attending this, could they train their own large language model, right? So it knows, so you could talk to it like a personal assistant. And the answer to that is no, because large language models, even the early ones like ChatGPT 3, cost between $100 and $300 million to train. So that's not something that you're going to go do, but it's okay because you don't have to. There are ways that you can take an existing system like ChatGPT, supplement what it already knows with your documents, provide it with ways to do things like look up your calendar and potentially get to the exact same thing, right? But creating your own large language model, that doesn't make any sense. Like, I think there's going to be very few companies that continue to build these things from scratch because they're so crazy expensive. It's hard to make any money and profit off of these things. And so, it just won't make sense. Having said that, there are ways that you can run a large language model locally. I have one that runs at home. It's not very bright, but it's a nice language model. If someone in your audience is curious about that, they can reach out to me on LinkedIn. I'll be happy to send them some links to things that they can do. But that's not something I would build a business on top of, right? It's more like a hobby for me. Okay.
And Jonathan, should we expect like how quickly could this happen for these large language models or many others that were coming to take over these manual and automated tasks, jobs that many people have today? How do you see that?
Yeah, why don't we do this? Why don't we get through more of the slides and come back to those kinds of questions?
Okay, yeah.
Fair? Okay. So I kind of answered this question. Why would you upload your own documents? And so the answer to that is it's better than traditional search. You can use it to train employees and a variety of things we already talked about. But as a scientist, one of the things that we noticed was when we were creating these traditional machine learning models, right? So I'm backing off of large language models again. We're talking about traditional machine learning models. We recognize, gee, we seem to go through the same steps over and over again. So what if we just automated that? What if we just let the machine do all of those steps? So that's what that's what auto glue-on is. So there was this idea called auto or automatic machine learning. And there were several different approaches to it. Google had a very sophisticated approach where they tried to have a model figure out what was the best approach. AWS took a different approach. They just basically said, we're going to try everything. It's just easier for us to just throw everything at it and just see what works in the end. And so the auto glue-on, auto glue-on, that's it down here. That's it down here. It is, what is that? 7 lines of code or six lines of code. That's it. Isn't that crazy? It's amazing. When I saw this, I decided I got to get out of this business. I can't be doing machine learning anymore because it's over. I'm going to have to go do AI. And so literally what this is, this entire line here, all it does is tell you where is the data. And all of the work actually happens on this line down here, the predictor. And the beautiful thing is while it's running, it's showing you all of its work. It's explaining what it's doing. And I'd be happy to talk in more detail about that, but we don't have the time for it right now. You can reach out to me on LinkedIn. I'm happy to talk to you about it. But yeah, 6 lines of code. So this is where someone could say, oh, I really need a model that's going to predict, what our sales are going to be in 6 months, or, how many employees am I going to need to service?
This model predicts that?
Yeah. Yeah. So that's not AI, right? This is just traditional machine learning. So you're going to create one model that does one thing really good. But the beautiful thing is, unlike before, where you had to hire a scientist, they had to go find all the data, they had to clean all the data, and then they spent weeks, if not months, trying to make the models. If you have nice, clean data, this does a better job than I can overnight.
Wow.
It's so fast. It's so easy.
Well, it's not replacing. They're not replacing it.
Yeah, it totally replaces me. Yeah.
Oh, it totally replaces.
Jonathan, sorry to interrupt, but actually someone here is asking a question to you specifically. It says, I have seen some individual companies making their own AIs. How is that different from what Jonathan is describing in terms of ability for a business owner to make their own LLM? For example, I know Tony Robbins is piloting his own AI for coaching. What would you call that?
Yeah, so it's not his own AI. So what it is, it's somebody else's AI, probably like GPT or something else, and then there's a little bit of code on top that is unique to him. There's a great lecture by Andrew Wynn, who's one of the great AI minds of our generation, and he says, look, if your business is a large language model from somebody else and a little bit of stuff on top of it, that's not actually a product. Like anybody's going to be able to replace you, and that's true. So like what you see when you see these things, they did not go and train their own large language models. There's no way. It takes over 400 people working for years to create GPT. And like I said, at the low end, it's $100 million. It's probably more than $300 million to do each version of GPT at this point.
Now, I don't want to stay in this subject too much, but there is something very interesting that I think the audience should hear from you, Jonathan, and it is that the Chinese have found a different way to do it cheaper. Maybe you can talk to us about that.
Yeah, so DeepSeek made a lot of noise, and it caused kind of a crash in the U.S. Stock market. That was a misunderstanding about what they actually did. So if you go read the research paper, they talk about this, it cost $6 million, right? That was the headline. They made it in the newspaper, $6 million to make a model. That's a lot less than $300 million. What the paper actually says is the last time they trained it only cost them $6 million. But they may have trained that model 30, 40 times, right? The other thing that we now know from DeepSeek is that they skipped the expensive part. So you can create a model that hates people, that tells you how to build bombs and how to poison your wife. That's actually pretty easy to do. The hard part is to take a model that's trained on all of the internet and get it so it's safe. So it's not making stuff up, so it's not lying, so it's not telling you how to kill people. That's expensive because to do that, Microsoft, OpenAI, Google, Meta, Amazon, they all have to hire human beings to interact with the AI and say, okay, you provide a prompt, that you have the AI generate, say, 4 or 5 responses to the prompt, and the human beings say, this is a good response, this is a dangerous response, never say that again. This is a very good response, this is a bad response, this one's lying, right? And that process, it's called reinforcement learning with human feedback, is really expensive, and it's slow because you have humans involved, right? As far as we could tell, DeepSeek mostly skipped that, right? And so
it's not entirely true.
Yeah, so I mean, there's some safety to DeepSeek, but you can get DeepSeek to say really awful things really easily, right? And so
Wow. Okay.
this idea that it was very inexpensive, not really true, because they only exposed how much it cost the very last time they trained the model, and they might have trained it 50 times. And then they skipped the most expensive part, which is making it safe. The DeepSeek will answer a lot of questions, but it also gets it wrong a lot of the times. Like it's really easy to cheat on large language model benchmarks. What you
Yeah.
do, you train the model on a benchmark. And so it's seen all the answers. It does a good job replying. So frankly, I don't really trust any of the stuff about what DeepSeek did. I mean, they had very good reasons to not tell the truth about how much it actually cost and how many people were actually involved and all that kind of stuff. It's an interesting model.
That's good.
I would never use it for business. I don't know what all is in there. So there's
Yeah.
those kinds of things. But anyway, so auto glue-on is a different thing. It's not a large language model. It lets you solve very specific problems very easily, but at the same level as, say, state-of-the-art, a world-class scientist could do. So if I was a small business, I had some specific problems I had to solve where I needed to, say, classify people as good customers, bad customers, good vendors, bad vendors. I had to predict a number, like how many people do we need to have show up for work on Thursday of next week, that kind of stuff. I would gather my data, make sure it's clean, and use AutoGluon.
Okay.
Okay, so if I want to leave you guys with one bit of like important kind of technical depth stuff, because we've been flying at a really high level, but I think this is an important thing to understand. AIs don't use words. So what actually happens is the words that you type, they come in and they're converted into what's called a vector. So a vector, if you remember your high school math, a vector is a mathematical object that has a direction and a magnitude. So here we drew one that's really simple, right? It's going this way a certain distance, it's going up a certain distance. That's a vector. And so that's what they actually operate on. But it's not two dimensions. Modern large language models like GPT or Llama from Meta, the large, powerful professional ones, everything you're typing is represented by an 8,000 dimension vector. It's all numbers. And so your words become numbers, the numbers are processed, and then a number comes out. It's actually 8,000 numbers comes out, and that's converted back into words. That's what's actually happening. Now, one of the beautiful things about this, so there's a wonderful paper by Google called Word to Vector or Word to Vec, where they created this and got it to work really well. And here's one of the magical things they did. So you have this vector that's describing the word king, okay? And then you subtract from it the vector that represents male. And so now you're sitting at about where the vector is for ruler, which is non-gender specific in English. And then you add the vector for female, and now you're sitting at near a vector for the word queen. So you can do math with words. But here's where it's very cool, especially since we have this bilingual or trilingual polyglot audience. You can take the American word for cheese, subtract English, add Swedish, and get the vector for ost, the Swedish word for cheese. And so languages appear to be in our own heads somehow. Translating from one language to another is a mathematical transformation in 8,000 dimensional space. And I just find that so mind-blowing. I try to share it with everybody. So by the way, here's the QR code to find me on LinkedIn. Love to talk to all of you. Happy to answer questions about Synerise, which I think is probably a very good solution for a lot of companies that are trying to very quickly make AI available to themselves for a lot of business needs, as well as Auto Glue-on.
Yeah, I would like to go to that slide also, and also, well, with the question that I mentioned earlier about is these large language models or these AI solutions could how quickly this can happen to replace these manual
Oh,
jobs
yeah,
that people are doing today.
Okay, so there are some jobs that, okay, let's start over. I think of AI as being as big of a revolution as when electricity came to businesses. And there are some similarities here. So when electricity came for businesses, there were lots of people that were scared for good reason, like it can kill you, right? Um, and then when it came to the businesses, what happened? We didn't need as many people because the looms could be run by a motor, and we could start to automate things, and we could build machines that did the same thing over and over again perfectly. And so you have this period of creative disruption where old business models and old jobs didn't fit very well anymore. It's like we didn't need people who were very sophisticated about, say, water wheels anymore to run the looms, because now we can just hook up a motor to electricity and it runs the looms. And so there's a period of time where this stuff comes in and it's very scary, and people do have jobs that aren't needed anymore. But then what happened was productivity grew, and when productivity grows, then there's there's more there's more money in the economy, there's more opportunity in the economy, and people reorganized. And some of those people that used to run the water wheels, they got together and they got hired by other people to do other things. Some of them learned more about electricity, some of them, did other things, but things that increase productivity ultimately increase GDP. And when you increase GDP, there's more opportunity in the economy, and it needs more people. The people end up doing different jobs, but there's more jobs available to them. So, like, who's going to be the first people to be replaced? Well, it's funny. 2 years ago, when I was inside of Amazon working on their large language model, trying it out for different things, I recognized that it had been fed a lot of Amazon documents, and especially a lot of Amazon's public release documents, because press releases are easily available and there's no copyright really on them. And so it had read a lot of those. It could produce you could give it any topic and it could produce a really nice public, Amazon PR document. And it's like, okay, well, PR probably not a lot of jobs for them anymore. So like those kinds of editor jobs we're not going to, there's going to be fewer of those people. When you want to produce marketing copy, AI can do that very well and can do it in a sophisticated way. So I used to run all of the outbound emails for Amazon devices. And so we had some very talented writers who had written like real books. And their job was to come up with the text for those emails. But, that's a lot of work and it's slow. So the most we could hope to do is maybe 8 different versions of an email. And then we would test to see which one worked best. Well, if you have a large language model, I could personalize each of the emails. So the 6 things that I show you are unique to just you. And the text that describes the offer or the call to action related to those 6 things could be written just for you. And so do we need marketing managers handcrafting 8 emails, or do we need a system that can write a personal email for all, 50 million customers? So those jobs are probably going to be reduced as well.
Yeah.
What we're seeing with computer software engineers, like I was when I was young and like my son is now, is that right now we're in a phase where a lot of companies want the computer software engineer sitting right next to the AI who's helping him or her write their code, right?
Mhm.
And so they tell me that you see about a 30% increase in productivity. So I think there's 2 ways you can approach this. If my programmers are 30% more productive, I could lay off 30% of my programmers and accomplish the same thing for my customers at a lower price, right? We still got the same stuff done. We didn't finish anything new, but we got the same stuff done at a lower price. And if I do that, the stock market is going to reward me, right? Because my profit margin is going to go up.
Yeah.
But then let's say there's this other company this other company looks at the situation and they say, hey, we have this list of stuff that we want to get done. And every time we make this list, they tell us that we can only do this much, right? We can't do all of it. We can only do this much. But if the AI makes my programmers 30% more productive, then for the same price, I could do this much. And if you think about it, customers are going to notice that, right? Between these two companies, the one that laid off people and got the little boost from the stock market for a little while, their customers aren't seeing any additional improvements, no acceleration of new features or improvements. But this company, which didn't lay anybody off, but got 30% more productivity, what did they do? Their customers are seeing bugs fixed faster, features arrive earlier, things that weren't going to get done for years are suddenly getting done. They're automating the fixing of a bunch of bugs, so suddenly bugs are just being ticked off as fast as they can. It's like, well, if you're a customer, you don't know which one of these things they did, but you'll recognize that, wow, this is the same old dumb company I had before AI. This company is suddenly so much better. I should buy their product because it gets better faster. Anyway, so that's what I think is going to happen.
That's good.
It makes a lot of sense. It makes a lot of sense. John, we have entrepreneurs in the audience tonight, and we have all the professionals too. In Latin America, there is a big interest, as we spoke before we start, to get into this race, the race of AI. Just because what you mentioned, I mean, everybody's looking to increase productivity, everybody's looking to fix their problems. So what would be your suggestion for any of these entrepreneurs? Step 1, step 2, step 3, to get into this AI revolution and take the best advantage that they can find in the market, how they should approach this?
Yeah, it's funny. As you were saying that, it reminded me that I spent a couple weeks working with the government of Kazakhstan, and they had Kazakhstan. If you don't know this, they discovered a large amount of oil in Kazakhstan some years ago, and they're now drilling and they have oil. So there's a lot of money coming into Kazakhstan all of a sudden, and so they hired McKinsey, which is an incredibly expensive, fancy-dancy consulting company. And McKinsey's doing a great job converting oil revenue into their revenue, right? And so I was talking to the government of Kazakhstan, and I said, look, here's what you need to do. It's foolish of you to go try to build your own large language model, because you're not going to be able to hire the sophisticated people that need to do it. Look at the trouble Amazon is having. Amazon has an enormous amount of money, enormous amount of resources.
Oh, yeah.
They can't catch up with OpenAI, right? So if you think, hey, we're Kazakhstan, we can write a big check, we can catch up with OpenAI, you're just wrong, right? So what I told him to do was invest all of your money. This isn't for your entrepreneurs, but for countries, invest all of your money in getting as many of your documents online as possible. Like get all of your historic documents online, get all of your government documents online, like fill the internet with every document you could find, photos, video, like get us all there and make it available for the large language models that exist to hoover it up. As I said, look, the language spoken in Kazakhstan is not very common. The dialect you speak is not very common. But the large language models will be able to speak it and understand it and answer in it if they have enough examples. Okay, so that's my advice to every small country, and especially everybody who has, who speaks in not the most common dialect or not the most common language. Like if you're not in the top 5 languages in the world, of course, Spanish is, that's what I think they should be doing. Okay, but entrepreneurs. So Tony, I think somebody mentioned Tony Robbins. So what did he do? So he's sitting on top of somebody else's large language model, right? And he's got this shim that he's got sitting on top of it that says, you are a Tony Robbins advice person, and here's all of Tony Robbins books. Just like I said, just upload all the books. So it can answer things like Tony Robbins. That's something that companies need you to do, right? You could have a company that, what do I do? I come in, help you identify all your documents. They're in PDFs and they're in all kinds of crazy formats. I automate the conversion of that stuff into what the model needs, and I show you how to upload it and take advantage of it. That's a job that, it's sort of like the Y2K job. It's going to last for about 10 years, and then it won't exist anymore. But you can make a lot of money doing that. Here's the next thing you can do. Agents, or agentic AI, is the idea that you have this large language model, which is just it's just a function call, right? And sitting around it is this code that prepares everything to call the function. So it's not a lot different from like the sum function in Excel, right? So like think about that, the sum function in Excel. You've all used it. Before it's called, do you think it's feeling nervous and wondering what you're going to do? No, right? After you've called it and it's given you the sum, is it plotting against you and like wondering if maybe you did the right thing and maybe you should do something different, or, thinking about what it should buy tomorrow? It's like, no, it doesn't do it. It's a function. All it does is it takes an input and produces an output. Large language models are just functions. They take a document, they process it, and they produce a document. They actually produce it one word at a time, but they produce a document for you. Sitting around that function call is all of the rest of the program. And what is that doing? Well, in the case of this retrieval augmented generation, where you've uploaded documents, when your question comes in, that little bit of code before the language model ever gets called, it goes and it finds related texts, like I said, to your question, and it adds that to the document. So now the document we're going to give to large language model is getting more sophisticated and more complicated. Now, what if the large language model, when it's starting to produce its document, it says something like, at this point, I really need to run this Python code, and then produces the Python code. Well, the code that's around the large language model, that's managing the large language model and calling the function, it receives a document back and it looks and it says, oh, the large language model wants to run this code. So what does it do? It calls another function and says, here's some Python code, tell me what it does. And it gets back the answer, provides it to the large language model, and then the large language model continues, right? So basically what happened is the language model said, I need to run this service. In this case, it was running Python. But the service could be, I need to know if it's going to rain tomorrow at this location. I need to know the stock price. I need to know the current time. I need to know if the ship has crossed through the Panama Canal. There could be an unlimited number of services that the large language model potentially has available that it could call, so it can produce a better output. Creating those services is a really good business, especially if you have access to some sort of useful information that other people generally don't have access to. I mean, I use the example of the Panama Canal because I'm sure somebody, in Panama has access to things like what ship is currently in the Panama Canal. And there are companies that want that data. And if you provide a way where that data is available to a large language model through a function, they'll pay you for it. They'll pay you every time they call it, right? And you'll make a fraction of a penny each time, but that fraction of a pennies add up pretty quickly. So all of the big large language models provide for these kinds of things. So you can register the service that you provide as a function, and then other people can call your service and use your service, and you get paid for all of that. Just like they provide a really easy way for you to upload your own documents so you can pretend to be Dolly Parton or whoever you want through all these sophisticated means.
Excellent. That's incredible. We're coming to the end of the webinar, but I think we have a question pending. Maybe Victor, can you help us with that?
Yeah, someone's asking what are the top 3 to 5 AI tools every small business owner should be using now besides ChatGPT, which is the common one.
So Microsoft, okay, a little bit of background.
Okay.
A long time ago, Microsoft invested in OpenAI, right? It was kind of just a nice thing to do because OpenAI was, probably not going to end up doing anything. But they invested, and they invested enough that they got a seat on the board. So years ago, in one of the board meetings, they got a demonstration of ChatGPT 3, and it completely blew their minds. And so that person went back to Microsoft, told their board, and said, this thing is actually going to work. It's going to be a really big deal. And Microsoft said across the entire company to all of its scientists, pause what you're doing. Everybody's going to work on this. And they all pivoted to creating features that used ChatGPT. So that's really powerful for me because the Microsoft subscription, so I just started a company a couple of weeks ago. The Microsoft subscription that I invested in is the one that gives me access to all of those AI features. So if you haven't used PowerPoint yet, where the AI features are turned on, you're going to be really impressed. It's like, hey, here's a better way to make this slide. We're going to make the slide prettier. We're going to add some, we're going to generate some graphics that match what you're saying. Like, boom, it's just done. You're writing a Word document, and it's like, how about I rewrite that to be more professional? Great. Boom, it's just done. You want to write some code, so you open up your code editor, you connect it to, say, ChatGPT or Gemini or any of the other ones, and boom, your code is just working, is just helping. You can ask the model to rewrite your code and make it better and look for bugs and solve problems. So I think the short answer is, there are tools you already use that you love, that work well for you. Have you turned on the AI features? Have you spent an evening just playing with them, learning what they can and can't do, becoming more comfortable with them? That's a real low-hanging fruit. You probably have far more AI features available to you now than you realize. So I would go after that really fast. Otherwise, so the documents that we write for AI that result in their responses are called prompts. And most of us write prompts that are a lot like Google searches. They're very short. They don't provide any information. And that's not how you should talk to an AI. You should write almost like, okay, have you ever watched your grandma try to use Google search? Right? So she's like, dear Google, I would like to know where I can find a restaurant that serves meals for people over 55 who are on dietary restrictions, especially diabetes. Thank you so much, Margaret. Right? Like they write like these crazy long,
Without my husband.
There you go. But yeah. It's funny. Grandma is writing the way you should for an AI prompt. It's providing a lot of information, right? She's getting some experience in writing prompts by just trying things is a good exercise, a good use of time. So one of the things that I try to do is get it to solve kind of complicated problems. So for example, I'll say you have a grid, it's 5 by 5. You are sitting at location 1, in the bottom left corner. You can only move left, right, up, or down. You can only move one space at a time. You're trying to move from where you are to this other location. You can't go off the board, and so I say, okay, take your first move, and then I'll have it like do the moves, and then I try to figure out how could I write the document so it gives me all of the moves. And then I look at it and I say, oh, it made a mistake. It went off the board, or it cheated, or it went diagonal. Like, so keep writing it until you can get it to do this, granted, artificial thing, but it's very specific because business problems are often very specific.
Mm-hmm.
You don't need it imagining the wrong answer. You don't need it, creating things that can't possibly be created. It's got to be grounded and it's got to be specific. And that's going to take some skill on your part. And so the price of interacting with the large language model keeps going down. They're often almost free, or they're free for a while. Like, try to give it some puzzles to work on that you come up with and see how well it does, and how well you do in explaining what you need to do. Because that's a real skill, and that's going to be a valuable skill. By the way, a prompt for say that Tim Robbins thing or whatever, it's not a couple sentences. It might be, if you were to print it out, it might be 6 or 7 pages of instructions. Right? These prompts are large, they're complicated and sophisticated. And being really good at writing those prompts is a lot like being really good at being a computer programmer, in that people will pay you a lot of money to do that and to write a sophisticated prompt.
Excellent, excellent. Well, I think Victor Andres and Stephanie would like to close, but before that, Jonathan, we have, as I told you, entrepreneurs in the list of assistants in this webinar, and I believe they might be very interested to have like a project for you, or maybe ask you if you know someone that might be interested in helping them with their projects. So I think that's an avenue that you will leave open, as you mentioned at the beginning. And I have something else for you. We have a client with a project of 140K that I think you might be interested in. So we can speak about it, because it's a real thing. It's a real situation that has to be solved, and I think AI can do whatever it takes to solve a big part of that situation.
Yeah, I'd
So
love to
with that said, and before Victor and Stephanie, great. So I want to, for my side, the presentation, Jonathan, has been really great. It seems we have learned a lot tonight, and I think everybody's very happy for knowing just a little bit, because you just scratched the surface of the subject. Know a little bit about this subject. It's not going to be the last time. So I thank you, and I thank everybody today to join us to make this effort. It's not going to be the last time. So with that said, Stephanie, Victor, you can say your words before Jonathan.
Yeah. Also, guys, you can contact us at contact@novacompany.com for more information. I really had a blast hearing everything that you had to say, Jonathan. Like Victor said, hopefully everyone else had the same experience like I did. I really enjoyed it. You said some things that I didn't know, and now I have a little more information. Now I'm more clear about the LLMs. So yeah, thank you, man. Yeah.
Yeah, that's right. And for the people who would like to contact, as Victor Andres said, you can scan also the code on the screen, and you can gain also exclusive access to more upcoming events from Nova. Thank you for joining, and thank you, Jonathan. Can you give us your final words to our audience, please?
Yeah, it was a pleasure. I love talking about this. Link with me on LinkedIn so we stay in touch. I'd love to answer your questions. This is my favorite thing to talk about, and I certainly appreciate the opportunity to do it.
Perfect. Thank you so much, and thank you, everybody. Bye.
Bye-bye.